Hi friends, welcome back to another session on operating systems. Now we are into the CPU scheduling and let's see the various criteria on which the CPU scheduling can be accounted for. So they are CPU utilization, throughput, turnaround time, waiting time, response time, and so on. So let's see one by one what they mean and how they are influenced by the scheduling. So starting with the CPU utilization, it is how effectively the CPU is being used. So when CPU is available, so how much of the time the CPU is working and how much of the time CPU is idle, either having no work or waiting for some external event to occur, all will decide the utilization of the CPU. So we want it to be as high as possible. We want to keep the CPU as busy as possible, and it is expressed as a percentile. Ideally, it is usually between 40 and 90% of time the CPU will be working. So the higher utilization, the better throughput and better resource usage we will have. And the measurement, the CPU utilization is a good metric when we are working with servers or real-time systems. So the servers, real-time systems, when we are working with them, the CPU utilization metric is a good measure of how efficiently our system is working and all that. Then comes throughput. It's a number of processes completed per unit time. So in a given multitasking, multi-programming environment, the number of processes being completed in any given unit time is what is defined as throughput. So it indicates the overall system productivity, and it all depends on how the processes are being scheduled, and throughput is one of the important metric to find out which scheduling technique is better for a given situation and all. And more the throughput, the better is the performance of the system. So it is a good measure when we are working with batch processing systems. So when we are working with batch processing system, then this throughput is a best metric to measure the system performance. Then we have something called turnaround time. It's total time taken to execute a process. That means it's not just the execution time, it is the time when the process came to existence. That is, with a request, a process has come to existence, a program has become a process, and then the time it completes its work, that whole time is called the turnaround time. So we have something called arrival time. That is the time when somebody requests some process to begin the work, and for many reasons the process may not be given the CPU, therefore it will not be running, and hence it will be in the waiting state. And once the CPU is allotted to that process, then it starts running, which we call burst time, and finally it completes its job. So the turnaround time is the time at which the job is completed minus the time when it arrived. So that's the total time from the arrival since completion. The total time is what is called the turnaround time. It is measured with a formula, completion time minus arrival time. So this includes the waiting time and the execution time and the time taken for IO activity, because this also IO activity is also part of the process. Therefore the turnaround time includes the waiting time. That means the time for which CPU is not allotted to the process, and when the CPU is allotted to the process, the time it takes to complete the task, that is the execution time, and in between it may keep working with IO activities, and all the time it takes to complete those IO activities all taken together. That makes the turnaround time, the time the process is waiting for its turn to get the CPU, and the process working under execution, and all the time it is waiting for some IO activities. And the lower the turnaround time, it is the better. So we would like to ensure that the turnaround time is as small as possible, and it's a good measure for short and user visible jobs. So the jobs which are short and the jobs which are very much visible to the users, that is foreground processes, it's a best tool to measure the performance. Usually if the process is running in background, it may not make much sense, but what makes sense to the user is what is there in the front end, so the user can appreciate if the response comes fast to the user. So it only matters when we are working for user visible jobs, but those jobs which are in the background, the turnaround time may not be that easily appreciated. And then comes the waiting time. It is the time a process spends in the ready queue. So we discussed earlier that there are various states of a process. So one of the states is the ready state. So how long a process is there in the ready state, that is what we call the waiting time. So the waiting time is also measured in terms of the turnaround time minus how much time it takes for a CPU burst, that is how much time CPU takes to run the program or the process, and how much time a process was waiting for some IO activity. So removing all that, that is, we are only worried about the process waiting in the ready queue, not waiting for the IO operation or not waiting for the process to get completed its execution. It's only the time the process is in the ready queue. So we want it to be as small as possible. So this is the pure time wasted without execution. Whereas in the CPU burst time, the actual code is being run, and in the IO time, some data is being transferred from main memory to the IO devices. So that's also part of the game. Therefore, we cannot assume the IO time as a wastage of time, but because it is slower, then we had given a separate name for that. CPU time is the one which is working at a higher rate compared to the IO. Therefore, we have separated the two actions, and we want to make sure that throughput is high. Then we don't want any CPU to wait for the IO event to happen for any given process. So when one process gets into IO burst, then the CPU may be allotted to some other. Therefore we have separated these two timings. But in all, the CPU burst time is also working for the cause, IO time is also working for the cause. So we cannot claim that the CPU is being wasted in any of these two times. So it is the pure time that is being wasted without execution. So that's the total time it takes from the initiation to the end is the turnaround time. In that, how much time we have used for running the code is the CPU burst time, and in that time how much time we have been waiting for the IO activity to complete, that is IO time. So leaving the CPU burst time and the IO time, what is left in the total turnaround time is what our process has wasted. So that is the waiting time. And the scheduling, we aim to minimize this waiting time. So we would always want to ensure that the waiting time for any process is ideally zero, but practically as small as possible. Then we have something called response time, that is the time from the request of the submission until the first response. If we are talking about one process is split into multiple time slots and worked one after other and all that, instead of the whole thing is working in one stretch like a non-preemptive scheduling, if we had something preemptive scheduling and one process is split up into multiple subtimes, and then when the process was initiated, from that instant till first time that process starts its execution, that time is called the response time. So it is crucial for interactive systems. That means when we are working with human interactions, then the moment we press some key or when we press a mouse button, we expect the response as early as possible. So the response should be as early as possible. So with that response, the human will press another button, and the human activity is so slow that the other works can be a little slower, but immediately we should get a first response. So that's what we look at response time, which is very crucial for interactive systems, and it is not same as turnaround time. Turnaround time is something from the request of submission till end of the process. So when the process completes running from till then, from the requested time, the whole time is called turnaround time, whereas in this case when it starts executing first time, that time is called the response time. So more details about all these times and their differences between them. Sometimes they look similar, but difference between them we look at when we are working with different scheduling types of algorithms and looking at preemptive, non-preemptive types of algorithms. We understand these terms more clearly. So this type of measurement and this metric is well suited when we are working with user interfaces, real-time applications. The moment we press a key, we would like immediate response. We don't want the response to be delayed for some seconds or something that irritates the user. Final result may come little slow, but immediately we should feel that yes, we have been acknowledged. The moment I press a key, something should start working on the screen. It may not be the final result, but at least some intermediate results I would like to see on the screen, and that's what makes the user satisfied, and that's what user wants. So when we are working with user interfaces like that is when user is interacting with the system, then this metric is very much important. So the overall what we have seen in this previous few minutes, throughput is the total number of processes executed in a given time. Waiting time is the time spent by the process in the ready queue. Response time is the time spent in ready queue to get CPU for the first time. Waiting in the ready queue and you get the CPU for the first time, that gap is what we call response time. And the turnaround time is the waiting time in the memory, that is the then the waiting time in the queue, then the time required for execution, and the time required for doing IO. All these time together is what we call the turnaround time. More details on this as we look into various different types of scheduling schemes, and then each of these we look at and see how each of these matter and what each one mean when we are dealing with different scheduling schemes and all that. So that's it for now. Many more issues to come. So please don't forget to like, comment, share and subscribe to this channel. Thank you.